Okay, ready? It's a contest. It's a contest. All right. I have picked two people, and they have no idea I'm going to pick them. And they're going to come up and have a battle royale. Now, what happens is they don't know, and they couldn't study for it. I understand that. And if they make mistakes, I'm okay with that. I'm all right with that. But they don't know this. But we're gonna have them come up and have a little battle royale. And so one person will go and they'll pick one, and they'll give the definite answer and say final answer, and it will say right or wrong. And then what we'll do is the next person will go, and then we'll go like that. If you make a mistake, I'm gonna call that strike one. Okay. So what we'll do is when you get the 3 strikes, you're out. Ready? Oh, okay. So who do I pick? Who wants? Okay. All right. Kyle. Gabby. Bring your own pencils. I have a periodic table right here. If you need a periodic table, I know you didn't study, and I'm okay with that. But I thought we'd just try this. And any of you who were not really good with this, you have to get good at it. Okay. All right. I pick a number between 1 and 5. What do you want?
3.
3.
1.
It was 4. So you can go first. Okay.
Okay.
All right, everybody be quiet, and when I say final answer, then that's what they're at the...
Do we just pick one?
Do we-
or we going
do we
Yeah, you
write
pick
it?
anyone you want. Oh, that was below the screen, sorry. Okay, wait a minute. Final answer?
Yes.
Correct.
Who's best at Fortnite dance?
Now,
Jonah laughed.
Final answer, yeah.
correct.
Final answer.
Correct.
Does that say hypochloric or hydrochloric?
Oh, I didn't notice that.
I can't tell.
I
Which
think you're
one?
right.
I'm just
All right,
following.
so number 2 is hydrochloric, so let's strike 1. Okay, sorry. All right, go ahead, you got your next one though.
Alright,
I did not, thanks for pointing it out, because I,
Okay, I just couldn't see, so I
all right,
didn't know.
no, you're right.
no. Wait. Now I'm second guessing myself. I think it's. Yeah. Cooper backside.
Final answer?
Yeah.
That's correct.
Final answer.
Correct. Now imagine if you're up there, okay? If you're up there, what do you, the ones they're picking, you know those? You go a little bit faster, Kyle. You get to pick anyone you want.
Wait, no. That's not right. With the test.
Final answer?
Yeah.
Correct.
Final answer.
Correct. Final answer?
Yeah. That's not right though.
That SN is 10,
Yeah,
so you can't
fees
use
higher.
Ferris. Okay,
Yeah.
that's all right. Strike 2. Cross that one out. You still win. You still win. It's only strike 2.
Can't vote too.
Final answer.
Correct.
Final answer.
Correct.
Final answer.
Correct.
That's not right.
All right,
Final
sorry.
answer. It's not right.
It's two nonmetals, so it'd be sulfur dichloride. All right, just so I do that, you guys leave, Let's have, Isabella versus, EJ. Now remember, I know you haven't studied, but this is well,
You're so silly. Okay.
I didn't see any.
Hi,
Hey, Alan.
Isabella, pick number two, 1 and 5.
Okay, 3.
3, what do you want? 2, it was 1.
Oh.
EJ, you gotta go first. Just get a pen or a pencil, doesn't matter.
Man.
This one is on.
It doesn't increase
Girl.
chances of being safe.
You
Okay.
can do this, right?
And the other will do it. And then you'll do that with your child.
All right, here we go.
Hope you do.
Second game, here we go.
Okay.
Final answer.
Correct.
Wait, where's the okay? Okay.
Sorry, I'll move my hands like the sideways.
Well, that's, I'm writing the word, it doesn't matter.
Final answer. Can you read? I'm
correct.
sorry. Okay.
Got so quiet all of a sudden.
Correct.
Okay.
Wait a minute.
Final answer.
Correct.
I'm trying to figure out what I was doing here. Final answer.
Correct.
Final answer.
Oh, tricky one there. Even though Plumbik oxide is what I was looking for, because you said peroxide, I could say Plumbus. I'll take that. Correct.
Final answer.
Correct.
Alrighty.
Wait, how many strikes?
When I did on the test, I got the O2. I was thinking of peroxide, but I wasn't saying peroxide.
Final answer.
Wait, which one did you do? The last one? I
He
couldn't see.
just did.
Number 20?
I did 18.
Yeah, and then I
don't know
just
what
did
she
20.
20? Okay, correct. Notice they're drifting to the left side, the right side a little bit harder. Which one do you do?
35.
Final answer?
Yep.
Correct.
Final answer. I don't know if that was right. Okay.
Correct.
Final answer.
Correct.
Where's the periodic? Can we look at the periodic table too?
Yeah, there's one in front of you or that?
Final answer.
Correct.
Wait.
sorry. Okay, final answer.
First strike, hold on. Cross that one out. Cross that one out, first strike.
Oh, yikes.
Somebody got it right.
Oh, no.
Another with the first strike.
Or wait, what is it normally? What is it
He
normally?
might be able to answer it, see?
Oh,
Yeah.
okay. Okay.
So can they go?
I think that one's right, because that one looks like it. But
That's a good point.
I don't know.
It has oxygen.
All right, come on, let's keep going. Let's go a little faster.
And if
Oh.
it has oxygen, then
Just kidding, just kidding. But don't help him. Don't. No, I'm just kidding. No, I'm just kidding. I wouldn't know it even.
Correct.
That's great. Okay.
Isabella.
Oh, yeah.
Just off from her first strike.
He's like commentating. Okay.
There's like name
gotta have a comeback season.
I know.
Makes
It's
it
tough.
exciting.
I think my pencil broke. Not gonna lie. I think my pencil broke. COVID. Okay.
Knocked over my pencil. Sorry.
Oh, okay.
That's true. Okay. I heard that. Right.
Oh, I'm just kidding. I don't know if I'm spelling that right.
Hey, wait a minute, please, wait a minute.
Wait. Okay. Just kidding. Do this one. Okay, just kidding. We're not gonna do it. Let's do this one. And that's, can we ask if like if it comes in like 2 or 3? No. Okay. Oh
Not
yikes.
now. Can't
Oh
ask
yikes.
now.
So yeah, let's just go do this one. Okay. Three. Okay, well let's
Final answer?
Yes.
Wait, strike 2.
Oh yikes.
Strike 2.
Oh
Cross that one out.
no. Okay. Do you know what it is?
I'm just gonna do it on here, I guess. Final answer.
Correct. It was Mercury 2 and it's nitrite. Nitrite. All right.
Oh no. Should I take one for the team and just play random? Or just, I don't know. I don't know.
You can do one one.
What is that? So, oh.
So I think we should just get the Falcons.
Which one to do? Okay. Final answer?
Yeah.
Yeah.
Correct.
After winning the Super Bowl, that's always really important.
Final
Let's
answer.
get it.
Wait a minute, you guys keep going up and down on the camera. Which one did you do?
36.
Can I? I'm gonna go 36.
What's up, John?
Correct.
Okay.
Yeah, that's because somebody in one of the states somebody talked about it, all this potential names.
Okay, but there could have been one name I
Correct.
picked.
Okay,
Oh. Isn't this so fun?
So
No.
much fun.
Okay.
Final answer.
Strike 1.
Okay.
Cross that out.
Oh yeah. Wait, which one?
Cross that out.
Alright.
Wait, do I have to, or can I? I'm gonna do something else. I'm not doing that.
Oh shoot. Oh, that's so stupid. Oh.
Don't get too fired up.
Okay.
I'm in the zone. Alright.
What do you think? Final answer?
Yes.
Correct.
Yeah, I think I'm gonna let him win with the next one. I think, yeah.
You don't have to do that.
I'm just kidding.
You're not saying now before she rises. Hold on.
Correct.
You can do it.
Well, I can't see what
Go
all the options are.
Isabella.
What, okay.
Thank you.
No, yeah, these are the harder ones. These are the harder ones.
I don't know what all was left.
What do you think?
I take.
Gotta be right. Gotta be.
Final answer?
Yes.
Okay, correct.
Because he just did the other one. So I did. Okay.
Okay, can I just erase this and start
I
over?
have to.
Yeah.
No, you gotta
No,
make
I
it
gotta
quick.
see what all is left. I can't make a bet without seeing all my options, because if there's something easy left.
You want to see them all first?
Yes.
Oh.
Go right ahead.
Oh no.
Okay, okay.
Go ahead.
Neither of them make a strike?
So what, wait, if EJ makes the next strike.
Final answer.
Correct.
Which one did you just do?
Choke
I
it,
did
choke it.
37.
Okay.
So-
It's just fine.
Jen,
Okay,
like, I pay him $10 and then he pays me
I'm not gonna do that.
Me.
$10. No.
What?
I'm not paying you $10.
What is that? Okay.
Look out.
Oh my goodness, I'm so sorry. What happened? I was crying. Oh no. Oh no. Is everything okay?
That's a foul.
Not do it on purpose.
All right, go ahead.
Check her up.
Oh no. Oh no. Okay. 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 I'll do that.
Final answer? Correct.
Yes.
Wait, why is Cooper nitrate? Is that right?
Which one? I don't-
Oh no, erase
She
that.
didn't-
Sorry.
She
Was
actually
that?
didn't finish that one. I thought she
Oh.
went to another one.
Oh yeah, I went to
She
another
just
one.
went to 2.
I think I
No,
forgot.
when the
I'm
camera, all right,
sorry.
when the camera fell,
I
when the
got
camera
lost.
fell, I don't think she went back to the one she started. All
Which one was
Okay,
that?
so
yeah.
she can finish
Okay, so wait a
Cooper
minute.
I'm
nitrate.
so
right,
sorry.
so, all right, she'll do that one next time. How about that?
Okay, I can. Okay,
I can just.
I forgot.
Alright, your
I'm
turn.
sorry.
EJ, come on, come on.
Got a little
Okay.
flustered. Good.
Final answer.
Correct. Back to 31.
So I have to do that one.
Yeah.
Okay. Wait, I remember Calvin said something. It was like F-E. Something. I don't know. Okay.
Come on now.
Okay. sorry. I'm so sorry. Yeah, we're just gonna do that. I'm
Okay,
sorry.
think
We're
out
just
loud.
gonna.
Okay, that's right, 3.
We're
Now,
just gonna do that.
all right, tell you what, I need to stop. I need to stop.
We're just gonna do that.
You know, when you take a test,
Okay.
and then you have peer groups, you go over it. The point is
You
that
deserve better.
everybody does. You're done. Okay, thanks.
What was that one? 30.
A poop rig is +2, so nitrate's -1. You have to have 2 nitrates.
Oh, I was looking at the wrong one. Sorry.
Everybody stop. Stop. Now, when you do peer groups, hang on. I'm kind of serious about peer groups because when you're doing peer groups, you're supposed to say, I'm not sure about that one. And you want to listen to everybody at your table. See that? So I thought this came to me just today. I thought, I'm going to try this, all right? And so if you did peer groups, you're supposed to say, I can do all of those. Isn't that right? So if I had called you up there and you couldn't do all of those, then something happened during your peer group. And you didn't care enough to say, well, I don't know why that's the answer, all right? So tell yourself, I need to master some of this stuff. I don't want you to be, only as good as a 10th grader at writing formulas, you got it? If you're taking a second year chemistry, you should be one of the best people in the school writing formulas, for example. All right, well, thanks for doing that. I know you didn't get prepared. You didn't know ahead of time I was going to ask that. So I just thought we'd play a little game there. All right, what I'd like you to do now is right behind Tim, there's a table. And I want you to pick up one of each stack. Pick up one of each. And I'll meet you back at your table. All right, everybody, pick up one of each of the packets.
She's a champion. She's just.
What now?
I take EJ and go Yeah, I'll.
Really? Okay, here you go. Huh?
EJ finds a way to beat Mike Tyson.
Okay. Does everybody have one of each? All right, hey, let's settle down. And again, I just kind of did that. I hope you don't. You guys are seniors. You can handle it, right? You can handle that. I know you didn't know I was going to do that. So anyway, okay. Well, we're getting ready to enter the next realm of chemistry, and we're going to get to that point. We're going to get to the point where we get in the labs. Right now, we're just kind of going kind of quickly through the stuff that's sort of like review. But it's not review to say, I only want to know as much as I did in the 10th grade. It's better. It's more than that. It's review, and it says, I'm going to be better than I was. As a matter of fact, I'm going to be really, really, really good at this. If you're really good at elements, or you're really good at writing formulas, or you're really good at the grid game, try to be really good at this. All right, that's your goal in second year chemistry. Now, this chapter here is about, you have chemical equations. So you're going to classify them. You're going to balance them. Okay, remember the little tricks? We had some little tricks on how to balance equations. And then we get into the mathematics. The mathematics of balanced equations, that's called stoichiometry. Do you remember stoichiometry? I want you to be really, really good. I would say if you can write equations or formulas, balanced equations, if you know stoichiometry, you're ready. You could actually go to a college class and get started. Stoichiometry is the key. It's one of the keys, almost the pinnacle before you get there. Now, we have other things to learn, but you can't sort of know this chapter. You said, I'm going to try to master this chapter a little bit. So the first thing I gave you was a sheet that I'll be using this packet just to teach with, so you don't have to turn any of this in. There's some practice questions here. We'll be using those, and I'll call on people and stuff like that. Anyway, there's that one. The next one is your homework. And this is what you actually do. And I'm going to do something a little differently this time. I'm going to teach for a couple days, and then probably starting next week, I'm going to have you get in small whiteboard groups. And so you'll get a whiteboard, and I might say I'm going to assign questions 1 and 16, and you guys would actually show the class how to do that problem. Now, I can either use whiteboards. I like to use whiteboards because then you can see it, or I can have you come up to the camera like that. And I'll probably have you in groups. Maybe I'll have you in groups of 2. And then you and your partner can talk and say, well, how do we do a question like number 1? How do we do a question like number 5? And then you talk about it, try to work, and then you just present it to the class. Now, what I'll do is, if you're watching them do it and you want to write down what they do, then you can do that as your homework. So say you're doing all the homework. I know we're going to do quite a few of them. We'll do probably maybe up to 20 of these questions in class. So if you want to wait on those. But anyway, that's eventually, that's your homework assignment. Okay, and the third one, and can I borrow yours for a second? This is the very first time that I've given this to you. And you can see it's quite a few pages, is that right? I had to make a decision. Do I want the school to have to pay for this paper? And I think in this chapter I did. Now, this is the author's study guide. Now, I haven't given you that for chapter 1 or 2. This is chapter 3. And I thought of all of the ones, this is the one that if you wanted to, you could use this and take this home with you when you're doing things. And it has a little bit of this. It has a little bit of that. And even in college, if you had this with you, and you said, well, at least it has the basics of stoichiometry in there. And you could actually just keep that with you. Now, you may not use it. It's very possible you said, I'm not going to use that. But some of you will end up looking through there and doing the example problems. I might do some of the sample problems in there. And that's the first time I've given you the study guide. So you don't have to do anything. You don't have to do anything to that. Everybody all right with that? Okay. So let's take a look. And the first thing I'm going to do is we're going to get ready to look at equations. And I got this out of another book. I don't think I give this, I don't think I hand this out in 10th grade, I'm pretty sure I don't. What do you know about chemical equations? Well, in 10th grade, I would have done something like this. I'll say, this is a symbol. So Ag is a symbol, and it's called a chemical, what? What is this called? A chemical, what do you call it? Chemical symbol. But what does it represent? If I write Ag, what am I actually trying to tell you that that symbol represents? What do you think? What is it? Element, right. So it represents an element, doesn't it? It's not an element, it's the symbol that represents an element, is that right? Let's do another one. Let's do H2O. And we don't call that a chemical symbol. What do you call that? It is a compound, but the symbol is called a chemical formula. Okay, so if it is a compound, we have a chemical formula. Okay, and that represents a compound. Now you know that if it's a metal or non-metal compound, it's called an ionic compound, but if it's actually non-metal, it can be a molecular compound, right? Covalent bond. And then what about this? H2 plus O2 yields H2O. We have a name for that. What's the name for that? Yes? That's a chemical equation. But what does it represent? Say it again. It does. It actually represents a chemical reaction. There's no reaction on that paper, but it does represent a chemical reaction. Now, what we do is we need to translate these. We know how to learn how to translate. And for example, this right here, you can say H2 plus O2 yields H2O. You can do that. But if we want to translate it, you would say hydrogen gas plus oxygen gas, and you might even have conditions. And remember this little thing here? Above the arrow, I might put conditions, like maybe I need a little electricity. A little lightning bolt there. Maybe a little bit of electricity, a little bit of a spark, and this thing would actually happen. I could actually cause this to combine with that to make water. Now, you also learned in 10th grade that there is something wrong with this. There's something wrong with the way I wrote it. Because I want you to be able to visualize that. If you said, well, I can visualize that. Here's an H bonded to an H. That's H2, right? There's an H2. And then I have an O bonded to an O. There's O2. And somehow, those are supposed to rearrange themselves and make what? And then you say, wait, something's not quite right. Isn't that right? Is there something, if I gave you some little toy set, and I gave you two of those, and I say rearrange them and make that, what would you think? Could you do it? Yeah, you could take one of those, and one of those, and one of those, but wouldn't you have something left over? So something's not quite right, because when they do this thing, they don't find you get this plus something else. That's all you get. So what's wrong with it? You know, I'm just reviewing. We have to do what? What's that word, Tim?
I'm not sure exactly what the word is.
And it's a weird word because when I heard it in high school, I'd never used that word before except in, balance, right? And whenever you say the word balance, you always have this picture of somebody keeping their balance. Because I was never taught to keep a checkbook, but my parents did, and they had checkbooks, and they'd say, well, we put this much money in the bank, and we wrote a check, let's put $1,000 in the bank, we wrote a check for $300 and $300 and $200. And you say, well, okay, then what happens? Then you subtract that, and it says we should have $200 in the bank still. Well, the bank every month sends a statement, now it's electronic, and they actually say, what if they had said that you only had $100 in your account? Well, that you would say, wait, something doesn't balance. So when an accountant balances something, he says, money in has to equal money out. Get that? If you start with $1,000, either you spend it and there's $200 left over, or something's out of balance. So when you balance an equation, you're just keeping track of all the atoms. You get it? So this can't be true because if I tried that, I would have something left over. It would be this plus something left over. And so there's something wrong with it. So it's not balanced. And so you learn how to balance things. And it's just kind of a little bit of trial and error. I see 1 over here, but I see 2 O's here. And when you balance it, you can only use, what are those big numbers called you put in front of the thing? I know these are called subscripts. Coefficients. You can only use coefficients to balance an equation. So now, when I say 2 of these, I'm going to draw that. Here's 1 H2O. Here's 2 H2Os. What do you think? There are 2 H2Os. You can't do that. You can't take that and make that. So what else? We're not balanced, are we? Let's take a look. How many O's do you have? 2 times understood 1. That's 2 O's. 2 O's. They're balanced. Those are balanced. How many hydrogens? 2 times, that's 4. Then, see? Oh, now that makes sense. And so you could actually draw a picture now and say, if I gave you that, could you rearrange them and make that? Yeah. Is that okay? Now, balancing does get a little harder than that. That was a pretty easy one, wasn't it? I got this out of another book. Another thing we're going to do besides balance is we're going to try to classify things. How do you classify equations? And take a look at this. This is one we start with. It says you have something plus something, and they combine. So you got several things that combine into maybe one. And what do you call that when you have something plus something and they creates 2 things kind of create into one? That's called synthesis, right? Yes, no? Okay, so now, this book gets a little more detailed than I did in 10th grade. It says, did you know that hydrogen, when it reacts with a nonmetal, what happens to it? What happens when hydrogen reacts with a nonmetal? You almost always get what kind of reaction is this? What's it called? What, in this case it is, in this case it is an acid. What about a metal and a nonmetal reacting? That's not an acid, but what do they have in common? 2 things combined to make 1. 2 things combined to make 1. Look at this one. Metal oxides. Did you know that metal oxides in water, what happens to them? Especially if it's group 1 metals, group 2 metals. If you put them in water, they're going to form what's this called? This is chemistry, okay? You use chemical terms. What is it? Right, it's called hydroxide. And if I had used barium oxide, I would have made barium hydroxide. And here, a nonmetal oxide with water. So here's a metal oxide with water, forms hydroxides. What about a nonmetal oxide? And then you have this acid, don't you? So anyway, this is 4 examples of a synthesis reaction. Okay, now you're right. This one happened to form an acid. This one formed a what? And a salt is an ionic compound. Almost always, it's a metal and a nonmetal. Everybody get that? This just happens to be the world's most famous salt called sodium chloride. Yes?
You just said that it's most of the time it's between a non-metal and metal. Other cases where
One more time.
Are there cases where it's an ionic compound forms between a metal and a metal, or non-metal and a non-metal?
One more time.
Well, you just said that it's most of the time it's a bond between a metal and non-metal.
Right.
So
Now,
there's exceptions
I would
to that?
say if it forms, how about that? If the compound forms, then you'll get an ionic compound.
Okay.
There are actually some of these that don't actually form, or if they do form, they decompose very quickly. Okay, good question. Now, what about this? Metal oxides in water, they do form, it's a synthesis reaction, but what's being formed here, even in 10th grade, you knew that a metal hydroxide, especially group 1 metal, group 2 metals, what do you call this? A base, okay? Not an acid, but a base, all right? And look right here, what's being formed here, a non-metal oxide and water forms an acid. So that's a little bit more detail than you had before. So when you hear about pollution, for example, what kind of things come out of a car that might be pollutants? A lot of it is sulfur dioxides. maybe even sulfur trioxides. Well, what happens when they combine with water in the air? What's that real famous term that if I go to New York City and look at some of the old statues and they look like the rock has been worn away, and if I go even in Egypt, some of the statues look like they've been worn away. Even in North Carolina, if you go to certain places in North Carolina, pretty close to Tennessee, you notice that certain lakes, all the trees are dead, and the lake, almost nothing lives in there. What's it called? I know you know, it's a two-word term. All right. What is it that makes statues look like they're being eroded away? This is a term that's in the news.
Climate change.
Okay, all right, here we go. Ready? First word, second word. All right, ready? Pick a letter. Calvin, pick a letter.
A.
Acid rain.
What is it?
I don't think that's a thing.
You're right. Acid rain. Have you heard acid rain? Okay, so how do you get acid rain? The clouds don't make acid. The clouds only can make water. But these things that come from our automobiles, for example, and they can come from other sources, but they tend to combine with water and make this sulfuric or sulfurous acid. And that's why there are places in North Carolina where, and we had to take them to court. Here's some places in Tennessee, and they're making all these pollutants. Now, these gases come this way because most of the time the wind goes west to east, doesn't it? They're coming over North Carolina. They combine with water, and then they fall into these lakes. And it kills a lot of the trees, and on the pH is really, really low in these lakes. And all the fish are dead and things like that. You have to go and take them to court and say, you can't let your pollutants come this way. And has everybody heard this before? Like, if you live on the coast of North Carolina, you can't have somebody up in Maryland, or I mean, let's say up in Virginia. Somebody up in Virginia, they can't build a great big jetty that comes out, and they can't build like, a jetty that comes out a quarter of a mile. You say, why not? Because along the coastline, there are these waves that take sand and then move it all the way down the coast. And they keep doing it all the way down the coast. So if you were to build something there, you would cut off the supply of sand to a lot of the North Carolina beaches. I know you don't think that's happening, but it does. They have to take them to court. They have to take that down. You have to take them to court and say, you can't stop, you're going to stop letting that pollutant come this way. Look what you're doing to our environment. Okay, let's go to the next one. What is the opposite of synthesis? Instead of things coming together, synthesis means to put together, doesn't it? Photosynthesis in 9th grade. You take carbon dioxide and water, and you're able to put them together and make glucose and oxygen, isn't it? So you can build something. Synthesize means to build something. Now, the opposite of that would be decomposition. I take a compound, whether it has 2 or 3 elements in it, and I turn it into 2 things. So one thing becomes 2 or maybe 3. So let's take a look at this one. What if you took a binary compound and you heat it? If I take a binary compound and heat it, then it turns into this and this. Everybody see that? Does that look like decomposition to you? Okay, next one. You take a metallic carbonate, calcium carbonate. This is known as chalk or seashells. Same thing. And if you heat that, what do you get? Look at that. Look at that, okay. How about metallic hydrogen carbonate, a bicarbonate? And you heat that, what do you get? Well, I think it's a little more complicated, doesn't it? And then they have other examples of decomposition. Everybody see that? What if you take a peroxide and you decompose it? What do you get? You usually get water and oxygen gas. You guys did a lab once where you took hydrogen peroxide and put a catalyst in there, and you did a test for oxygen gas. Remember that? Peroxides like to break down into oxygen gas. Yes?
Would hydrolysis fit under decomposition? Or
Okay, hydrolysis. All right, for example, water, if you use electricity, you can actually split that into this, and this is not balanced. But I would say, yeah, this is definitely decomposition. there's a picture back there, and you see electrolysis. I could have asked the school to buy about $150. That's how much that cost. And I would have to fill it with water, but I would probably put a little bit of salt in there. And I put a little bit of salt in there because I need the electricity to, pure water doesn't conduct electricity. But if I put a little bit of salt in there, I can get a good flow of electricity, and then I get a lot of electrolysis to take place. And so you just take electricity, hook it up to water, and you'll see, I don't know if you can see back there or not, but you notice that one of those, the middle tube simply supplies the water. The tubes on the left and the right are the products. And so one of the products is oxygen gas on one side, and the other product is hydrogen gas. I know it's far away. Can you see which one is there more of? Is there more hydrogen gas or more oxygen gas? And if you think about that, water is 2 parts H and 1 part O. And so that's a great question you asked, EJ. Great question. Electrolysis, I think that's what you were talking about, right? Electrolysis of water.
Yeah.
You can actually have electrolysis of many things, but I think that's the one you were talking about. I could take a compound like this. You probably don't remember everything, but there was a video I showed you in the 10th grade, and this guy named Humphrey Davies, and he made this great big battery, and he actually started showing that some of these compounds could be decomposed, and he discovered elements. Remember potash? Potash was stuff that ashes from fires and stuff like that, and he moistened it a little bit, put electricity through it, and he saw this shiny, shiny metal, and it was potassium, see, from potash. He had another one, he discovered sodium. See, sodium and potassium are so reactive. They almost never are formed just as an element. They're always combined with something else. So he used decomposition to break them apart, and that's how he discovered some of them. Okay, great. I love that. All right, next one. The next reaction would be single replacement, where usually you have an element and a compound. And what you do is sometimes this element is able to kick this one out. Now, if A kicks B out, okay, here he is. C got kicked out, didn't he? Then A will form a compound with C like that. Now, we had this before in the 10th grade, and I'm going to review a little bit here. Because compounds are written metal and then nonmetal, ionic compounds are always written metal and then nonmetal, A is most likely to be a metal because A is kicking out the metal part of this compound, right? This must be a metal. This must be a metal. And what do you think C is? It's probably a nonmetal. In this case, the metal A kicks out the metal B and forms that. What if, let's try another set of numbers. M plus XY yields, what if M, that's a bad letter for nonmetal, isn't it? How about N for nonmetal? What if what if this is a nonmetal and this would be the nonmetal, wouldn't it? Nonmetal. And so what would you get there? It's still single replacement, but what would you get here? Metals kick out metals, but nonmetals kick out who? Nonmetals. So Y would be by itself, wouldn't it? And then you'd form a compound XN. Is this bringing back any memories? Bad memories? No, good memories? Yes.
If the X and a Y are both non-metals.
No, not X and Y. That's a good question. Single replacement almost always takes place with ionic compounds. I like your question. I'm not saying you couldn't get single replacement with non-metal. Let me see if they give examples here. Here's a metal replacement. Aluminum is going to kick out the iron, so I should see iron by itself, and I do. And aluminum is going to form a compound with nitrate, and it does. Next one, active metal. Sodium, potassium, any group 1 metal is very active, right? Chemically active. If you take sodium and combine it with water, and we did that demonstration in 10th grade, and it was very violent. A very violent reaction takes place. What did it make? And I told you that sometimes, if you think of water as HOH, it helps to understand what's going on there. So what's happening? The sodium's going to kick out what? Hydrogen, and then it's going to form a compound with OH. So it'll make sodium hydroxide. In the 10th grade, what I did was I had a bowl, and it has some water in it, and it has some sodium, but then I put some phenolphthalein. Phenolphthalein is an indicator. It only changes color if it's a base. And it was all clear, and then I put the sodium in there. It reacted with the water violently, and then you saw the phenolphthalein changing. That gave me evidence that I was probably making a hydroxide, sodium hydroxide. Okay, so what we're going to do tomorrow is I want to spend a little time. We'll finish this, and we'll practice balancing equations a little bit, but I do want to get to the mole concept kind of quickly. So we'll learn how to balance equations, then we'll get into the mole concept, all right? All right, thank you.